Welcome to today's E100 02 launch webinar from EcoVapor. We've got Jason Rowe, Chief Executive Officer, Hans Mueller, the Chief Operating Officer, and Jeff Wilson, the Strategic Marketing Manager, joining us from EcoVapor. Jason, I'm going to hand it over to you.
All right, thank you, James, and thanks everyone for being with us today. It's a pleasure to be with you. So good morning and good afternoon. I've noticed that we also have some attendees from overseas, so happy that you can be here with us today. In terms of a quick agenda for you guys, we're here to talk about the E100 launch, which we'll certainly get into. I'm going to start with a little bit of an overview of EcoVapor and what we do, and then we'll roll into there with the evolution of the E100. How it works, how it installs, and some of the value proposition that we believe it presents. But yeah, happy for you guys to be here with us today, and let's get going. So, I don't think it's any surprise for anybody on this webinar to understand that our industry is under a little bit of pressure right now. I mean, it's difficult to have these an energy conversation without talks of energy transition. But the thing that we think is oftentimes overlooked is this fact that access to reliable, affordable energy is just fundamental to the way we live our lives today. And I think it's hard to not say that, our industry is that our industry is going to play a very pivotal role for decades to come. And oil and gas will continue to have a very important part of the energy mix. And so, but with that in mind, I think we'd probably all agree that we're learning and we can do better. And we're going to continue to face this rising pressure to reduce our carbon footprint and reduce our emissions. And so, there's pressure coming from a variety of different sources, and you can read some of them here. But, our stakeholders are holding us accountable for a variety of things. I mean, one, you look at access to capital, it's reducing. You look at cost of capital, it's increasing. You see some of the regulations that are changing, that are coming our way. But also, whether it be federal or state gas capture rules, ultimately investors demanding more, better ESG performance, better disclosure. But I think one of the key things that's also evident and pretty obvious in what we see today, that transparency in our emissions and in our carbon footprint is something that is driving a lot of action. You see monitoring now from satellite, from airplane, from ground-based continuous monitoring, from drones, from people on ground. And so with this, we're learning more about our footprint. We're learning more about the emissions that are coming from industry. And most importantly, we're learning about what we can do about it. A few statistics for you guys that, we always like to start with here is that, so first off, 40% of our carbon footprint in the industry is coming from venting, flaring, and fugitive emissions. So you're talking about 3 billion tons of CO2e emitted by the upstream industry annually, 80% of that stemming from the production process. And then 60% of that 80% is really focused on what we would call waste emissions. And what we mean by waste emissions, this is flaring, this is venting, this is your fugitive emissions. And, we sit here saying, well, why waste these energy resources that we've worked so hard to produce? Why emit what we can sell? And so this is at the heart of who we are and the heart of what we do. And so EcoVapor, we offer solutions to eliminate natural gas flaring and venting. And our goal is actually quite simple: sell more, waste less. I think one of the things that we're very proud of is that our value proposition that we like to talk through with our customers is one, that we can take a meaningful bite out of these emissions that come from our production process. But in the process, we also offer compelling ROI to our customers. And we think this dual value proposition is powerful and something that we're very proud of. And so ultimately what we do, we offer products that are products and solutions that are here to enable increased sale and decreased emitting of natural gas in both the oil and gas vertical, but as well as, we've started our early focus on the renewable natural gas space as well. Applications like landfill gas, applications like biogas, including swine, dairy, etc. But at the end of it, what we do, these products are all centered around the safe capture and treatment of gas to enable it for sale. There's a variety of causes that can lead to what we would call your routine flaring and or venting. And probably the number one cause is just straight lack of takeaway capacity, gas takeaway capacity. And so this is something that we've been addressing pretty aggressively in the lower 48 here in the US. You see more and more gas takeaway capacity in the major oil producing basins. But another major contributor to why we flare and vent gas is, and probably less talked about, is the contamination of these gas streams. And ultimately, if you're a midstream provider, or if your pipeline has specs and you fail to meet your oxygen or your H2S specs, and you want to sell that gas, or if you want to continue producing, a lot of time your asset can get shut in because this gas is off spec. And so these contaminants can come from a variety of sources. If you're talking about H2S, sometimes oxygen, it can come from the reservoir itself. But then if you look at the production process, you look at the tanks, you look at the tank loading, you look at some of these situations, air has a funny way of finding its way into these production processes, whether we like it or not, no matter how hard we try to keep them out. And there are existing processes that we use to try to deal with some of these problems. You've looked at techniques probably like a gas blanket, where you increase the gas inside of the tank to try to keep some of this air out. That oftentimes can lead to venting if you have any type of surge in production. At the same time, it doesn't help in the truck loading process. You look at VRTs, a good tool to help separate some of these vapor streams, but it's all upstream of the tanks, and so you're still ignoring all of this gas that's downstream of the tank. And so what we like to talk about is, look, let's capture all of this gas. Let's capture all of this gas. Let's treat this gas so that we don't flare this gas, and so that we sell this gas. And we believe to meet our industry's gas capture and emissions reduction targets that we're all setting out, we have to consider this low pressure side, and we have to consider these tank vapors, which, by the way, is also probably the richest gas stream on the site. So certainly compelling argument to make sure that we do something about it. So just to give you just a little bit of a deeper dive on some of the products and solutions that we have, all centered once again around our theme of eliminating natural gas flaring and venting. As you can see, we focus largely on the oil and gas vertical and the renewable natural gas vertical. And some of the, starting off here, tank battery vapor management. We have the ability to enable 100% gas capture. And a lot of this is enabled by our 02 product line, which we're here to talk about today, including the launch of the E100. And this is centered around the ability to remove that oxygen from these gas streams, and ultimately enable 100% sales. We also have an H2S solution, our Sulfur Sentinel, that is now out in a variety of applications in the oil and gas space, as well as renewable natural gas space. And then we also have solutions that can help to eliminate venting, and this is all based upon tank pressure control, the ability to use things like makeup gas and a blower to make sure we're managing that right pressure window to ensure that we are not venting from our tanks. In addition, we have mobile solutions. We're starting to look at different applications that require shorter lengths of time of operation, things like a tank clean out or well testing, flowback, these other areas where we might be flaring gas unnecessarily for temporary operations. And so, how can we help to mitigate some of the flaring and venting from these processes as well? And if you're unsure about what you might have out there, what the contaminants in your gas stream may be, or even, what your emissions footprint may be, we also have the ability to run site assessments out on your sites for you. And then on the renewable natural gas side, also, similar, the ability to treat, purify this gas, ensure it's sales ready, whether it be H2S, whether it be oxygen, a variety of products there. But then in addition, we're proud of the fact that we offer service on all of this. We're behind the scenes. We generally have remote monitoring on all of our assets, and we're there for service, calibration, whatever it might be. But in addition, we have service centers set up in major basins to ensure that we're there for the proper service of our assets. Being that we are here to cover the 02 E100, figured it might make a little bit of sense to give you a sense of what the 02 actually does. And so here's a quick schematic to kind of help you understand. You could see kind of a typical well site schematic on your left side, and then the schematic on the right side, which actually features the 02. So on the left, as you can see, this has a VRT taking some separation of VRU, sending the sales gas down to the sales line that's been captured from the VRT. But as you can see, you're still foregoing all of these rich tank vapors, and you're foregoing a lot of the gas that could be sold there. On the right side, what you see there is our 02 down there. And what we're doing here is we're essentially bypassing a VRT. You can continue to operate the VRT. You can bypass the VRT, whatever the decision is, or if there's no VRT, no problem. You send 100% of that production to the tanks. And then now what you're seeing, though, is that downstream of these tanks and downstream of the VRU, we're inserting the 02, which is taking all of the oxygen out of that gas stream. We're reducing, significant volumes of oxygen-rich gas and, getting it down to less than 5 ppm consistently. And so, but ultimately what the 02 is here to do is to decontaminate that gas stream to ensure that that gas pipeline that's running to the processing plant is sales ready and that there's no risk of shut-in, and it also enables you to turn off that flare. So EcoVapor and our products have evolved through time, and really it's been about meeting the customer needs and the challenges that we've faced, and it's all based upon the material field experience and deployments that we've had. Starting with our E300, and so 300, that means 300 MCF per day. Which is, we talk about the 100, that means 100 MCF per day, 1200 MCF per day. And so the E300, though, is widely deployed. It's been around for several years, and it's on north of probably 130 to 150 sites at this point. And so starting there is really where we got our footprint, got our operational experience. But then moving forward, what about applications like a central processing facility where you might have large amounts of gas that need to be treated and handled? And so that's where the E1200 came into play. We started the 1200 MCF unit. And then from there, H2S, a growing concern, a growing issue that we needed to help handle. So the sulfur sentinel. And then as we're here to talk about today, we'll get into the E100. And as we've evolved, down this path, particularly with this increased focus on emissions reduction, what we found was that it was important to be able to address these smaller volumes. There is, as you guys know, there are thousands, if not hundreds of thousands of producing sites that, are later in their life on the production decline, may not be putting out the amounts of gas that have been, that they had in the past. And so ultimately what we want to do is have an application that we could come to a brownfield application where your production is declined, or, where the carbon reduction targets still can't be ignored, and ultimately have an economic solution there for you. And so hence where the 02 came into this. But then as you can see in our product pipeline, we're still moving, we're still going, and we're coming out with more and more products that really are all about still enabling, the reduction of the flaring and the venting in our industry, but all incorporating the learnings that we've had through time and based on the history and the learnings and the success that we've had with our products to date. And as an introduction to the E100, it's probably good to just introduce you a little bit to the rationale as to why we wanted to develop this E100. And, as I kind of mentioned, we wanted to introduce solutions that don't just help on day one of production when we have large volumes of associated gas coming out, but something that can be economic throughout the well's productive life. This enables us to have these longer term relationships with our customer. And ultimately, we want to be able to sit here and say, we have an economic solution for every stage of your productive life on these assets. And so as you can see here, what we're showing on the bottom, transitioning from an E300 to an E100 to an E25 over time, which is on our development path as well. It gives us the ability to handle this entire life of well that not only can generate a meaningful financial return, but as you can see here, meaningfully reduces the emissions footprint from a site. And as you can see here, getting upwards of 20,000 metric tons of CO2e reduced from these applications. So it's something that we're proud of, that we can take a meaningful bite out of these emissions. But once again, the ability to grow with the customer, the ability to have these flexible leasing arrangements to where we can be there and economically adjust to your LOE needs as we continue to move through the production process was important to us. And hence why we wanted to launch the E100. So with that, I'm now going to pass over to Hans to actually talk to you a little bit in more depth about the E100.
Thanks, Jason. We are excited to introduce the next step in the path to zero routine flaring of tank vapor. So let's jump right in. The E100 builds upon really everything that EcoVapor has done and learned from operating tank vapor processing and purification products for the past 11 years, namely the E300 and the E1200 02s. But the smaller capacity of the E100 really means that operators now have options that are focused on the economic capture of smaller emission streams. So saying it differently, we can still get it all. But the E100 really is designed to purify tank gas streams of up to 100 MCF per day. Just like always, so that we can meet midstream gathering specifications and that all of that vapor, full capture, all that gas that's produced on the site can be sold. So today we really do have a choice whether to flare or not, even at existing sites where production has already declined. We started testing the prototype E100 by processing rich tank vapor in July of this year. And the way that we do that is by stress testing it. And those oxygen stress test results can be seen on the right-hand side of this slide. To perform these tests, EcoVapor literally hooks up an air compressor upstream of the 02 and opened a valve. And in this case, the E100 did pretty well. This is actually a live production site. This is not a lab. So if it seems like our confidence is high, that's because it is. We started out by testing with about 5,000 ppm with great results. You can see that O2 on the discharge was barely affected, if at all. And keep in mind that the pipeline sales tariff is 10 parts per million. So after seeing those initial results, we cranked it up to over 20,000 parts per million at the inlet of the skid. That's 2% oxygen, or about 10% of the overall stream being air, and the E100 handled it all. By the way, the prototype has been running flawlessly without a single shutdown since startup. We're proud of that. And the production models that we're starting to put out in the field are even more versatile than that test unit. So if it's all right, I'd like to take a quick look at that test while it was happening live.
My name's Eric Anduri. I'm the engineering manager at EcoVapor Recovery Systems. And we're here today testing out our 02 E100. It's a smaller version of our E300, which we have a lot of out there. So what we have is a VRU pulling gas off of the tank battery you see over here. And in order for it not to go to a combustor or flare, it comes through the compressor. It comes through our 02 system here, where all the oxygen gets removed, and then that gas then goes down the sales line. What we have is an oxygen analyzer cabinet here. This is our PLC control cabinet. We're looking at a 02 touchscreen, and what we're going to do right now is run a little test where we actually inject air into the inlet of the 02. What we expect to see is that inlet O2 on the top right of the screen is going to increase potentially up to 10,000, maybe even 20,000 ppm, and we'll see that the outlet oxygen will be much less than that. I'm going to go ahead and run the little test here. Here we go. Starting to see oxygen on the inlet. We're simulating the oxygen coming from the tank vapor, which is a common occurrence. Okay, so we're at 6,000 parts per million. That's 0.6% oxygen right now. So we're hovering about 7,000 now, and keeping it pretty low on the outlet there. I'm going to go ahead and increase it a little bit too. We are reporting this into our SCADA system, and yeah, reporting it onto our platform where we can see it anywhere in the world. So now we're doing good. Now we're cooking some oxygen. Got over 1% now, over 10,000 ppm. Our reactor temperatures have increased slightly here, which is expected with that much oxygen. And doing great on our outlet, still at 1.2, basically 0 ppm on the outlet.
And I think that's the bottom line, 0 ppm at the outlet. That allows us to sell it all. We definitely had a lot of fun testing the E100. And if it's okay, I'd like to highlight the ESG performance along with some of the economic benefits of full vapor capture with the case study. So let's take a look at the same facility in the real world that was configured a couple different ways. We measured the results of each configuration, and let's take a look at how they compare. In the first scenario, for the first 77 days of the test, the initial 11 weeks, vapor recovery tower was employed to capture flash vapor upstream of the tank battery. Separators were held at 50 psi, and the VRU maintained a 3.0 psi target pressure at the VRT. All vapor generated within the tank battery, as well as oil hauler vent vapor, vapor associated with the water stream, were flared that way they were able to control the emissions in the way that they were. And they also didn't need to worry about oxygen content exceeding the pipeline's 10 ppm tariff. So said differently, flaring was continuous 24/7. And this setup really established a baseline for oil production and recovered vapor volumes so that we could compare them to the second test. In the second scenario, this was actually run subsequent to the initial one. So we're a little bit further down the decline curve on the second set of 77 days. In this instance, the VRT was bypassed. In the slide for simplicity's sake, we show it removed, but actually we just routed around it. So all liquid hydrocarbons were sent directly from the separators straight into the tank battery itself. Also, a liquids knockout and active oxygen control were installed, and that was tied to the same VRU that was on site before. In this case, though, it was reconfigured so that the suction was coupled with the vapor space of the tank battery directly, and then the discharge from that compressor would flow straight through that liquids knockout and the oxygen control skid that we call the 02. The VRU was set to maintain 4-ounce pressure target at the tank battery itself. So now the tank pressure is actively controlled rather than passive emissions control, where you require the tank battery itself to pressure up to push that rich vapor over to the flare tip. As far as production, well, the flare was turned off because all of the vapor was being captured, all of it, including the oil hauler vent vapor. So the only flaring that occurred during this period was associated with VRU downtime, and that was just during some routine maintenance and an oil change. We actually make, I think, life a little bit easier on the VRUs than they might be when they're coupled with the vapor recovery tower. Since this setup, the second test occurred in the subsequent 11 weeks of the initial test, you'd probably expect to see slight decline in production, right? Well, not actually, and what we saw, some things were expected and some of it wasn't. The recovered volumes jumped by 37%. That's no surprise because we're capturing all the gas that's normally flared. Also expected was that the heating value, the BTU content of the gas was increased by about 564 BTU per cubic foot. But what caught my eye, and I thought was very interesting, was that oil sales increased, and I use those words carefully. This is actually measured at custody transfer, not a Coriolis meter or something like that upstream. And again, this was a bit of a surprise, but what we found is that it's 100% repeatable. And what's going on there is that increased liquid sales are due to giving those rich NGLs another bite at the apple to be sold as liquids because they're recondensing after or downstream of the VRU into a liquid, being scrubbed by that liquids knockout and sent back to the tank. I expected that was actually going to create a propane loop where we'd use some horsepower to spin propane and butane in a circle. But based on the liquid volumes, again, as measured at custody transfer, a good portion of those condensed NGLs remained in the liquid phase. So we saw about a 3% increase in oil sales. And again, that's been absolutely repeatable. Breaking that down, what we're seeing is that we got about 2.5 times better ROI than using a vapor recovery tower alone. And that's simply because you're able to capture the full stream of gas and also sell all the liquids as liquids. This also resulted in about a 2/3 reduction in regulated pollutants, as well as unregulated greenhouse gases associated with the full recovery. And again, these results are absolutely repeatable. You're able to see the production uplift day one when operation starts in every instance.
Great, thank you. Thanks for taking us through that. So that was an excellent example that Hans took us through of this mutual benefit that we like to continue to highlight of not only knocking meaningful chunks of emissions out, as you saw 66% reduction in that example, but also the meaningful economic uplift. And so what we're highlighting here on this slide is, not just, the kind of the instantaneous or early production benefit, but also this life of well benefit. And as you can see here, as we transition from year 1 all the way through year 5, and transitioning from maybe an E300 to an E100, how we can continue to generate meaningful free cash flow based upon these different LOE options that we have by reducing, from an E300 to an E100, or maybe even to smaller in the future. It's as you see in this example, and you can kind of get a sense of what our standard economics are run at. You see we've got a $3 per MCF gas price. We're talking about NGL valued about $30 per barrel. And as you can see, this is a well that starts with about 5,000 barrels of oil per day and 72% decline curve. So meaningful reduction year over year in the production, but generating almost $500,000 of free cash flow over this time. And if you can also get credit for the NGLs, depending on what your contracts look like, upwards of $1 million of free cash flow over this time. So once again, meaningful economic uplift to the operation, in addition to the meaningful reduction in the emissions footprint. So, one of the key applications we had in mind when we were targeting, when we targeted the E100 development, yes, was one, to backfill some of the 300s or 1200 applications over time, but also there's this vast population of mature, productive wells that may still be flaring, or even worse, venting in some cases, that can still, for our industry to meet the targets that we're after, must be addressed. And so in this case that you're looking at here, we deployed on a brownfield asset. This is in the Mid-Con, pretty far down in its decline in terms of its production. And what you can see here is before we were installed, and they were realizing zero gas volume after 45 MCF per day. As you can see, the realized gas price, this is one, just based on the natural gas price itself, but also this BTU uplift that we get based on this being some of the richest gas streams out there. And you can see what the net revenue per month ends up looking like. But then, even more meaningful, you get a sense of the CO2 emitted impact here. You're talking 2,500 metric tons, even on some of these lower productive wells. This is an application that took us, I actually think Jeff himself that's on the call with us today was out doing this application. And I think it was, he showed up in the morning and it was running by that afternoon and selling gas later that afternoon. So ease of installation, and what we believe these are compelling figures, even for some of these mature fields or these brownfield applications that you may have in your asset base today. And then similar, as we've talked about the life of well, financial performance, equally important, the ESG performance. And so we want to highlight just what that environmental benefit can look like by capturing and not wasting this very valuable stream on site. You could see upwards of 20,000 metric tons on a production site being prevented from being emitted in these applications. That's a combination of the early days, maybe with a 300 and transitioning to a 100 and maybe to another one over time. But it's very compelling to see that, not only are we taking a real economic boost to our production here, but really reducing our carbon footprint, which, as we talked about earlier, we're really being held accountable for. And so now with that, I'm going to hand back over to Hans to talk through one other item that we're very proud about, which is actually our ease of operation. We pride ourselves on being transparent to the customer, and our ease of operation, our ease of installation is something we're very proud of.
Thanks, Jason, and that is absolutely right. We sure are. Ease of installation, operation, and maintenance really were some of the primary objectives are identified when EcoVapor set out to build and design the E100. Something that's been important to me since day one of EcoVapor is ensuring that we're designing and producing equipment that fits into your site operations, not the other way around. You shouldn't have to bend the way that y'all are doing things just to fit a new technology into the site. And I think that the experience that we've gained over the past 11 years is really on full display with the E100's ease of installation and operation. If it's all right, let's demonstrate that live with the first install.
Loaded on our trailer is our very first E100. We are going to be going out to a location for an existing customer. They currently have an E300 on location. We are going to be taking that E300 off location and installing the new E100. They're downsizing. At this particular location, we had two E300s at one time when the facility first came online. We have since removed one E300 and only have one, but production has declined to the point where an E300, just even one, is uneconomical. So we have designed a new E100. This is the very first one that we will be installing and testing.
Awesome. Yeah, the E100 really is easy to install, both for initial installs as well as what Casey was just talking about there, where we can replace the higher capacity 02 equipment. It could not be easier. In that second scenario or I guess what we just witnessed, where the equipment starts out right-sized and the well site progresses along its life cycle, production declines. When you do replace the E100, no modification of the facility's piping is required. We've designed it so that the inlet and outlet flanges, those are the only two process connection points, are in the identical spot as they are in the larger units. So this allows for a quick swing of the skid and bolt up, and then you're off to the races. When the higher capacity E300 is replaced with an E100, the operator typically relocates the larger equipment to new locations where its capacity matches the initial production rates. And EcoVapor encourages this, actually. We assign leases to the skid itself, not the facility. And of course, that's true for new installations as well. But we've made these as easy to move around as we know how to. They've got built-in forklift slots, lifting eyes on both the E100 and E300 and 1200, and it makes moving their small footprint around a breeze. What we found is that, and really what our goals was to make sure that the E100 represents the next step in the industry's progression to zero routine flaring and facilitating full tank capture. So now operators are able to reliably eliminate routine flaring emissions over the full life cycle of the well, so that you can continue to convert that waste stream into revenue. Thanks for your time. Curious if we have any questions from the audience.
Yeah, Hans and Jason, we do. We have a few questions. One is, are the models the same, the different sizes, or are there differences between the features or operation of these different sized units?
Really, the goal was to preserve all the sensing data, certainly the performance. So really, what you're looking at with the E100 is just a scaled down version of the E300, where we still have oxygen analyzers on board to ensure that performance is met. We're using the same type of proven catalyst, the same technology, the same approach. Really what we did beyond scaling it is just try to make it as easy as possible to work on. The catalyst swaps are a breeze. Those still are on track to happen every 12 to 18 months. So it's just kind of like the little sibling.
Okay, thank you, Hans. There's a couple of questions here that are somewhat similar. One is, what's the operating ranges of the 300 and 100? And another participant was asking, is there a certain time that you'd switch? Is there how would you know?
That's a great question. So we do have a little bit of overlap in the operating capacity of the E300 and the 100. We get a turn down ratio of about 6 to 1. So an E300 is capable of treating down to about 50 MCF, and in some instances lower than that. But again, economics are important to us, and we want to facilitate as good returns to the operators as possible. So that's why there is a little bit of overlap built in there. It doesn't have to happen on day one. The cutoff isn't at 101 MCF. But how that actually happens is EcoVapor wants to be the one to tell you, that we think that the equipment out there that you might have or that you do have might be oversized as that well as the well moves along the decline curve. So we want to be the ones to actively let you know that, hey, we might be able to actually further the economic returns that you're already enjoying with the E300 by swapping out that equipment, and then it also frees up that equipment to hopscotch onto one of the new facilities that was recently drilled.
Okay, another question on the economics. If the economics we showed, they're asking, wouldn't we also have to change the compression or downsize the VRU, or is that in the economics, or how would we handle that?
Well, I think that actually represents further opportunity to boost your ROI by right-sizing the compression. And it's not an accident that compression providers are coming out with smaller and smaller equipment to capture these lower streams as well. So really, what we're trying to do is work in conjunction with the equipment that's available from some of these compression providers to, again, right-size to the stream that you've got. We want to right-size to your well site, but also do that over time.
And just to add one thing to what Hans has said there, I think the question may have been, are we including cost of VRU in our economics? And the answer is yes. I mean, we do include that when we run the economics. All applications do not require that we run behind a VRU, but for those that do, then we are absolutely including that in the economics that we're presenting here.
Okay, another question on the economics. A participant is asking, are there significant ongoing expenses to operate and maintain these units?
No, not with the 02. And the good part about that is, well, it's part of the design. We've eliminated all moving parts. There's no rotating equipment. Monthly oxygen calibration is a good idea, just to make sure that analyzer is reading accurately. But when it comes to maintenance, catalyst swap intervals of every 12 to 18 months, and typically, well, I think our record on that is under an hour of downtime. But in almost all cases, when we show up in the morning, you'll be back up and running by lunchtime. And again, that's once every year to year and a half.
Okay. Final question. I've got a participant is asking if you could explain the process for actually removing the oxygen.
Absolutely. Yeah, it's a catalytic process, which lends itself to why it's so effective. What we're doing is we're heating that stream that contains the natural gas as well as the oxygen to a point where once we run it across a precious metal catalyst, that it facilitates a reaction that generates a little bit of CO2 and a little bit of water. And it's actually less water and less CO2 than the initial concentration of oxygen at the inlet. Given that CO2 tariffs typically are 3 to 4% in gathering contracts, EcoVapor has never ever once had an issue with anything that's contained in the effluent of these systems. It's we just remove the oxygen, make a little bit of water, make a little bit of CO2, and the gas plant right downstream is well equipped to take care of that.
Okay, then another question's come in asking about the pH level that the 02 can handle, and what is the H2S concentration that's a specification for the unit.
Great question. As far as the pH level goes, I think the first thing to state is that what comes in is what goes out. EcoVapor, we specifically designed the catalyst to avoid any partial oxygenation of the hydrocarbons. We actually create zero acids. So if there's anything that's coming in, shouldn't really be an issue, but it probably will be that same pH going out. What was the second question, Jeff?
H2S. How much H2S can be handled?
Not much. Good question there. The catalyst is very sensitive to H2S, and that's why EcoVapor not only offers equipment, but also partners with other providers of gas sweetening equipment so that the H2S can be removed upstream of the vessel itself. EcoVapor's Sulfur Sentinel product is an extremely reliable, easy way to do that. But yeah, that's a really good question. H2S is one of the things that the catalyst is sensitive to. The only other thing to watch out for there is compressor oil. So that two-phase liquid knockout that I was describing in the case study, it really has two purposes. One is to make sure that you're selling oil as oil, but the second is equipment protection. And what I mean by that is screw compressors in particular, but really most oil field compressors have lube oil contained in that stream. And with the screw compressor specifically, if the coalescing filter tears, you can get a good amount of lube oil, which is engineered to be sticky and coat surfaces. And that's exactly what it will do. It doesn't harm the catalyst, but it can mask it and prevent oxygen from interacting with those active catalyst sites. So if we're able to keep compressor lube oil out of the stream, as well as remove H2S that might be present before it gets to the skid, this will make sure you have a great time.
Okay, thank you. Another question came in about the moisture content after the catalytic reaction. What is that moisture?
So it's really a function of I guess, two things. One is oxygen content and the type of hydrocarbons being processed. So the stoichiometry varies a little bit in terms of the ratio of CO2 and water that's generated. For example, with methane, it's a 1-to-1, but it changes as you work your way up the hydrocarbon chains. But the important thing is that you make less water than you do oxygen coming in. So, you know, when in certain applications that we've seen, especially in the biogas industry, where they're running oftentimes into a distribution line, that water does need to be monitored, and in certain situations, dehydration process is required. But we've only seen a couple of those over 500 sites that EcoVapor is deployed on.
Okay, Hans, isn't the I'm going to ask this question myself. Then the moisture content isn't about half of the mole fraction water and about half CO2 generally?
Generally, yeah. It varies a little bit, whether it's propane, butane, pentane, hexane, or whatever it is that's reacting. And it will be the longest chain that goes first. But yeah, I'd say rule of thumb, about half makes sense.
Okay, that's all the questions I've got, James and Hans and Jason.
Excellent.
Thanks, Jeff.
Yeah, thank you, Jeff. Thank you for facilitating that. And if there are no more questions, I guess let's take this opportunity to thank you, everybody, for your attention and your time today. We truly value it. We know you're busy, and appreciate you spending a little bit of time with us this morning or afternoon, depending on where you are. So if there are follow-up questions, please do submit, and we will do our best to answer them as quickly as possible. You can reach out to myself, Hans, or Jeff. And we look forward to keeping in touch with all of you. Thank you very much.
This concludes today's EcoVapor E100 launch webinar. Thank you for coming, and have a good rest of your day.